Okay, we're going to work on finding X-intercepts, roots. They're also known as roots or zeros. So I'm going to build two questions here. One is an equation, and it looks something like this. Let's say x squared plus 6x. Actually going to leave it as that. And then another one we're going to deal with is y is equal to x squared minus 64, let's say. Okay, so we're going to deal with these two questions here. You can watch. First, we'll start with, we'll call this question number 1 on this side. So we'll deal with this one first. This one, there's actually a couple ways we can solve this. The simplest one is probably just common factoring. So we take a look at this. Y is equal to x squared plus 6x. If we look at the coefficients, this is a coefficient of 1. Technically, nothing's really there, right? So common factors of 1 and 6 are just 1, and dividing by 1 doesn't do anything. But there's a variable, and the variable occurs in both of these, so we can actually take a common factor of x out of this. So y is equal to, we'll take the common factor out. Okay. X squared divided by x leaves us with just x, and 6x divided by x leaves us with just 6. Okay, wonderful. So we factored the equation, but we want to find the x-intercepts, roots, or zeros, whatever it is you want to call them. In order to do this, we have to set the y value to 0. So we're going to take our y value here, and we're going to say y is equal to 0. So 0 is equal to x plus 6. Well, think of this like it's in its own set of brackets. And these are actually two different terms. So here's term 1 in this bracket, and here's term 2 in this bracket. If we multiply them together, if we multiply them together, we get a 0. The only way to do that is if one of these is 0, we just don't know which one. So what I'm going to do is shrink this a little. Wonderful. So how can we find out? We're going to split these two. We're going to split in two different equations. So 0 is equal to x, and 0 is equal to x plus 6. Well, 0 equals to x, that's already solved. We've got one of them. The other one we have to isolate for x. So when we move 6 to the other side, we get negative 6 is equal to x. So what does that tell us about this? That means when we look on the Cartesian plane, one of the roots is at 0, the other one is at negative 6. And we know that because the a value is positive, it opens upwards here. Okay? So these are our two roots. So we're going to double check this question in Desmos here, okay? Oh, it's okay, guys. Oh, it's okay, honey. Y equals x squared plus 6x. Here we go. And if we take a look, we have one at negative 6 and one at 0. Great. One method of solving it. Let's go back to it. I'm going to show you another method in here. The second question is a difference of squares. So for difference of squares, we know it has to be subtraction. It's okay. It's okay, honey. We know it has to be subtraction, and we know we have to be able to square root both the first and the last term, okay? So just to test these two, we're going to find the square root of x squared, and we know from doing this before that it's just x. Wonderful. And can we find the square root of 64? What would the value be? 8. And technically, remember we talked about this before, it's a positive and a negative 8. Wonderful. So we're going to put this right away into a factored form. Y is equal to, let's put the 2 here. The first value in both of them is going to be the square root of the first, so it's x. Okay? And the second value in each of them is going to be our other two answers. There is a positive 8, it's okay, and a negative 8. No, math is so scary. So we have our factored form. Same as the last question, we need to set y equal to 0. Okay? So we replace y with 0, and we're left with, again, think of it like two terms, x minus 8 and x plus 8, okay? So because of that, term 1 times term 2, one of them must be equal to 0. So we split the 2, and we say 0 is equal to x plus, perfect.
X subtract 8.
Great. And then what would I do?
You isolate x.
Okay. So on both occasions, I move those values to the other side. They just become opposites. So we have x is equal to negative 8 and x is equal to positive 8. Great. So let's double check this on Desmos again. Our question was originally y is equal to x squared minus, I think, 64. Perfect. Positive 8, negative 8. We zoom out a little. Here are our two quadratics working out perfectly. Now, those are actually the simple ways. There are actually other ways to solve these questions. So I'm going to try to quickly do them. Actually, what I'll do is I'll do one of each because it'll take a really long time. We'll do the first one. Do you remember product? Have you ever heard of product sum factoring? Okay, product sum factoring comes from the concept of y is equal to, we put things into standard form. A plus B and plus C. We're going to look for two terms that add up to whatever the B coefficient is. And those same two terms also need to multiply to the C coefficient, okay? Have you ever seen this method? Yes. Okay, so they call it product sum. There's a lot of different things. They've probably called it something else when they explained it to you. Let's take a look at our two questions. Our first question was y was equal to x squared plus 6x. So we have an a value, it's 1. We have a b value, it's 6. What would our c value be?
0.
0. Okay. So we can always turn it into a factor form. Our other question, y was equal to, now this one's a little trickier, x squared minus 64. Is the minus 64 the b value or the c value?
C value?
Why is it the c value? I'm going to tell you you're right.
There's no b value?
Well, yes, so you can say we have no b value. The c value, it's because it's a constant. So we're going to say negative 64 because there's no variable attached to that. Remember, the c value is the constant. There's no variable. So in that case, what is the b value?
1.
1 would exist. We would draw 1. It would just be an x. If there's nothing, what represents nothing?
0.
0. So plus 0 x. And don't do that, okay? And lo and behold, we once again have an a value, a b value, and a c value. So what we did is we just turned them into a standard form. We plugged in some zeros that weren't showing up before. And now we can product sum these if we really want to. So let's think about this quickly. In fact, actually, we might be able to do this one relatively quickly. I need two values that are going to, in the first case, they need to, Bianca, add to b, b is 6, and they also, don't do that, multiply to c. C is 0. What two numbers add to 6 and multiply to 0?
6 and 0.
6 and 0. In order to multiply to 0, you must have a 0. So we have 6 and 0. Well, how would we write that? We would write it like this. Y is equal to, whoops, that's supposed to be a bracket. Go see him then, baby. We would have x plus 0 and x plus 6. Well, the plus 0 becomes x. And if you recall from our last version, we're right back at where we were on the other page, right? Great. This one here, two values that add to b. b is 0. And those same two values need to multiply to negative 64. Well, things that add together and cancel out.
Positive and negative.
Yeah, they got to be the same values, right? And what two numbers multiply to 64?
8.
8. Well, we need one to be a negative 8. Perfect. Negative 8. A positive 8. Those work out very nicely for us. And once again, we're right back where we started. X plus 8, x minus 8. So even though we had those special shortcuts on the other side, we can do this as product sum. And finally, we could technically have put all of this into the quadratic formula. Negative b plus or minus the root of b squared for ac. It's a good thing to have memories. I hear you saying it. We found an A value, it's 1, B value is 6, C value is 0. Plug them all in, you'll get your x's. Same here. A value is 1, B value is 0 in this case, C value is negative 64. Plug it in and that works. So we've actually done 3 different ways. There's product sum, quadratic formula, or you could go back and actually just do like your common factoring or your difference of squares. Did we double check this on decimals already? We did, right? Yes, I think we did. Let me just make sure. Yes, we got our roots right. Perfect. Works out wonderfully.